going to do a lab on igneous rock crystal formation. And I have 3 igneous rocks here. This one is called obsidian. It cooled very, very quickly. Okay, this rock formed on the surface, most likely exposed to the air around it. And it cooled so rapidly that crystals did not form, and it gives it a glass-like appearance. Okay, here we have basalt, and basalt has very, very small crystal formation. If I was in the light, you would be able to see a glitter effect on the end. Okay, so with a magnifying glass, you would be able to see some crystal formations. So that tells me that this rock cooled slower than the obsidian, but still not slow enough to form any noticeable crystals. And here we have granite. Granite is another igneous rock. So you can see crystal formation here. There's a big crystal there next to the number 2. That tells me that this cooled slowly, because remember, when magma or lava cools slowly, that allows crystal formation to happen. Okay, so we have 3 very different rocks. They are all igneous rocks. They are completely different though in appearance and in texture. And that's because of their composition and also because of the rate at which they cooled. So our experiment, we're going to study how cooling affects crystal formation. I'm going to use a chemical called phenyl salicylate, and I'm going to do the experiment for you, and you get to pretend like you're doing the experiment yourself. Okay, so first thing, we need to take our slides, and we're going to have a room temperature slide. We're going to have a cold slide. This is ice. And put that on the ice. And then in this beaker we have hot water at 45 degrees Celsius. That's about what we want. So I'm going to pour it into the cup. Okay, and the rate that the liquid phenyl salicylate cools will be much different on each one of these slides. Okay, so I'm going to go ahead and get this solution here and open this up. And I'm going to fill the test tube right here. So set that there. With my spool. With my funnel. There we go. It's in solid form now. I'm going to dip it in here and wait for it to melt. Basically all that I'm doing is I'm taking the liquid phenyl salicylate and I just put 1 drop on each side. So there's a drop on the hot, sitting above the hot water, and then I also have a drop on the room temperature slide and a drop on the cold slide. My stopwatch is going, and I'm just waiting for that liquid to solidify. And as it solidifies, it will start forming some crystals. I'm having a little trouble here with the cold slide. There's condensation on the slide preventing the phenylsalicylate from solidifying. So I'm actually going to have to redo that slide. But the room temperature is almost done. You can see it's almost solid now. And later I will put these up to the window and you guys can see the crystals up close. All right, so 120 for the room temperature. And then the hot water looks like it's almost solidified, not quite. Okay, so 152 for the hot. 1 minute 52 for the hot. Here goes cold. Okay. Okay, there we go. Cold is almost already solidified. Yep, solidified after only 12 seconds. So here are our times again. 1 minute 20 seconds for room temperature, 1 minute 52 seconds for hot, and 12 seconds for cold. And let's check out these crystal formations. Okay, you can see pretty big crystals there, especially that one on the end. Like it actually made a pretty good sized cube shape. So that's hot. This one is room temperature. Definitely see some crystal formation, but nothing like the hot, because I mean that cooled slowly, and you can see how it helped the crystals form. If I can get it into focus. So hot, room temperature. Still a big crystal there on room temperature, but most of them are smaller. And here's the cold. The cold's it solidified in like what, 12 seconds. Very, very small. You can see the individual crystals there, and they are much, much smaller than the hot crystals. So you can see here through this experiment that the temperature that these slides rested on and the rate at which that phenylsalicylate cooled had a big impact on the crystal formation. Same as with igneous rocks.